Our presenter this afternoon is going to be Vaagn Toukharian. He is a senior software security engineer with Qualys Web Application Security Scanner. He's been involved in the security industry since 1999, and his experience includes working in certificate authority systems, encryption devices, large CAD systems, and web scanners. Outside of work, his interests include Ironman triathlons and photography. So can everybody join me in welcoming Vaagn to the stage?
Hi, everybody. Can you hear me? Great. I'm going to present the talk that is a result of research that me and two of my colleagues did over the summer. It's basically an introduction to WebSockets and an introduction to all kinds of trouble coming from WebSockets. So what is WebSockets? WebSockets is part of HTML5. We will go through a little bit of introduction, then we will show what's up there, how people use them, and then what is bad about it, and then finally what we can do to make things better. So WebSockets are defined with RFC 6455, and it's a protocol that lets you develop applications that have two-way full duplex real-time communication. Before WebSockets were introduced, people were trying to create these persistent connections through some workarounds like long polls, or trying to use raw sockets from Flash. But those methods have inherent problems, and those problems are things like inability to know how fast you have to poll the server, and stuff like that. So WebSockets, as I already told, is defined in RFC 6455, and it has two parts. One part is the JavaScript API, which is very simple, defines a couple of functions and a couple of event handlers, and enables a developer to write a code that can move strings, blobs, and array buffers around. And using that tunnel that is the WebSockets, you can move around data in binary or in text in any arbitrary format, or you can wrap it in JSON, XML, HTML. So here are a couple of examples of WebSocket emulation for those browsers that don't have it yet or didn't have it. WebSocket.js was Flash raw sockets based workaround. SockJS client is a JavaScript library that recreates functionality with long polls. So some features of WebSocket. WebSocket is starting and being enabled through regular HTTP handshake, regular looking HTTP handshake, and because of that, it can go through proxies. Well, it does from time to time because there are some problems with proxies. There is a ping and pong that tries to keep things moving, and data frames that are coming after the initial connection is established don't have HTTP headers anymore because they become something similar to raw sockets. And that's the good part, because you are not forced to move that HTTP data back and forth. But there is also a bad thing about it, because now you're missing some of the features that we all love. Headers and cookies and authentication mechanism are gone. There is also a secure version of WebSockets, WSS, which is almost same as HTTPS for HTTP. So here is how Handshake is done. Browser sends connection upgrade with a pseudo-random number in sec WebSocket key. Server answers with response that includes base 64 SHA-1 hashed value of that key plus a GUID that is well known. And why it's done? It's not done to make things more secure or anything. It's just there to identify the protocol, so the client knows the server is WebSocket server. I will show a little demo here of a usage, probably not the best or the most creative usage of WebSockets. This is a small demo application of a web server, not a web server, WebSocket server, written in Java, running inside processing environment that connects to my webcam, hopefully, and then it will transfer all the data from the webcam over the internet to this client. All right, and this client here now is talking to the server, and you see the functions light up there. That's the receiver function, and whenever I move the mouse, we have send functions working. So basically the source code for this almost these 10 lines that are on the screen. So the main thing about this demo was to show this funky background, and here is where you laugh. All right, back to the real stuff. So WebSockets JavaScript object is pretty simple. These are screenshots of the functions, WebSocket object and its event handlers. A data frame is also pretty simple. It has I'm not going to go through all of it, but I'll point out the most interesting parts. One of the most interesting parts of it is that the length is variable. You can go from 7 to 64 bits of length. And there is also a mask that is transferred with every data frame. And the mask is used to XOR the data in a data frame, and it's done because some of the network devices were confused. They would treat the body of the data frame as some different protocol. So you could have cross-protocol attacks or whatnot. So the masking here doesn't add any security to the data frame. It's just scrambling data. The variable length. The length field, as I told, it can be as small as 7 or as long as 16 bit. Sorry, 64 bit. And last 3 rows on a screen show a possibility of representing the same length value with 3 different ways. And that may be a bit of entropy for covered channel. Could be used to establish a covered channel. So here is an example of SCIP dissection of the protocol, which shows that the data frame itself is very small. And data frame security, there is no data frame security intended by design. So what we can find in real life, who is using WebSockets? Of course, there are some web applications, mobile applications that use WebSockets that basically are similar to web apps. And some interesting things like these little guys, PIC microcontroller that can run WebSockets. And you can have very rich web interface for it, and looks like future SCADA or SCADA-like problem in the future. Servers and clients are in abundance for WebSockets. All major browsers except IE do support it. All major JavaScript frameworks do support it. And here's the list of some some server-side implementations that have some full compliant, RFC compliant support, and some others are moving in that direction. Almost all programming languages now can be used to write WebSocket servers. User capacity with WebSockets is very interesting because it depends what you want to do. If the application you're designing really needs full duplex, real-time communication, then WebSockets is the way to go. And its capacity is similar to HTTP with the same limitations that are based on file descriptor numbers or number of concurrent connections server can handle. But if your application doesn't need those, doesn't need that full duplex real-time communication, then WebSocket is an overkill because it doesn't scale as well as HTTP does. Because with HTTP, if you are not required to sit there on the long pole, you can reuse that connection. You can have more users than connections. Whereas with WebSockets, each user is a connection. Performance and bandwidth usage are great. Well, the little demo that we showed is not a real life application, but we did an experiment and tried implementing the same with long pole and WebSockets. And on the header overhead, we saw 25x difference because the headers are sent in a very beginning, HTTP headers, and then each data frame can have overhead of as low as 2 bytes. So after browsing the internet a bit, we couldn't find anything interesting, any applications that are using WebSockets that are not playthings, but are real-life applications. So we wrote this WebKit-based crawler that goes and tries to crawl the whole internet and tries to find WebSocket usages. So we went through Alexa 600,000 websites, top 600,000 websites, and found some cases of usage. And then when we looked closer, what we found that first of all, there are not many. It's only less than 1% of web applications, top 500,000 web applications use WebSockets. And then it's even less if you look into the details, what's up there. The 95% of those guys were using the same vendor for customer support chat. If you take that out, then you have even lower numbers. It's single digits per 100K. And that's surprising. But why? We think, as with any new technology, people are afraid of it. It's really hard to set up the secure version, WSS. Browser support is not there. IE 10 will support it, and before that it's not, and looks like not all of the browsers have it, so people don't want to have something that won't work on IE because they love IE. And the protocol itself still changes. And debugging and hacking tools are not there, or they are there, but they are coming along slowly. So we have another demo. This is basically a WebSocket application that is written in C++ that connects on a port 9002, waits for the compromised browser to talk to it. This is browser exploitation framework. It's not powerful like Beef or any other guys. It's just for demonstration how WebSockets can be used. The main difference here with other exploitation frameworks is that the whole communication is through WebSockets. So if you had a firewall or any security device that would gonna catch it, it would not catch it now, because none of those devices will understand WebSockets. So let our client connect. So client is connected, and we have abundance of choices. We can do stuff to the browser, to the web page, the compromised browser's web page. We can get the HTML out of it. We can activate a keylogger. And then I type my username and password. And then we get the captured stuff. And you know my password now. So we can do other things with this framework. We can DOS any WebSocket server if we give its IP address and number of connections, so it will try to drain the WebSocket connection pool. We can crash the server, the client, or do a screen capture. All right, so we're shutting this down. So what are the problems with WebSockets? WebSockets are not a panacea. They are not going to solve all the web application security problems. All problems are still there, and WebSockets will add some more interesting things to those problems. So basic stuff, if you can sniff HTTP, you can sniff WebSockets. You can intercept and overtake WebSocket connection the same way as HTTP connection is done. Interception is done with regular HTTP. There is one good thing. There is supposedly this restriction that you cannot have WebSocket unsecured WebSocket connections from HTTPS. RFC points that out, but so far only Firefox implemented it. So one more problem here is that browsers don't restrict number of WebSocket connections they can initiate. And if malicious server wants it, or malicious JavaScript wants, it can spin off as many WebSocket connections as it wants, and maybe Safari and Chrome will become very heavy. Firefox here is restricting to 200 connections, which more or less makes sense. There are, it's hard to imagine an application that really needs more than 200 connections from one web page. A denial of service on a client side, on a server side. The little demo application that I've showed has that capability. Basically, what it will do, it will open large number of WebSocket connections on a remote WebSocket server. And this becomes easier with WebSockets because you don't have to create this persistency of connection anymore because it's done for you. Whereas with tools like slow lorries, slow HTTP attacks, you are creating that persistency. So how are browsers doing in this front? So as we already know, the mixed content handling, Firefox is the only champ here. Firefox doesn't support WebSockets from web workers, which is probably good because then you had this crazy mixture of lots of threads and lots of sockets. Maybe not, maybe yes. And message sizes now got changed with RFC. I think it's all the way up to 2 gigs, and that may be a problem because if a mobile client gets a 2 gig message, it may be overwhelmed. So as we already know, IE doesn't support it. All other browsers kind of do. So we are all here for security, right? Well, looks like nobody is here for security, but anyways, I'll share this little bit of information with you guys. So how do we make things more secure? How do we go on with making them better? We need to first understand those things. So for WebSockets, we need to see what's going on. What does WebSocket traffic look like from different clients and servers, and we need to be able to manipulate it, and we need to have proxies that support it, and so on. So far, this is the picture. Wireshark parses it, shows you the data. Same with Fiddler. Again, read-only support. Chrome Developer Tools have a nice WebSockets tab there. And Zap is in a making. They are going to support full-blown WebSocket fuzzing, but it's not in I think it's not in a latest version yet. So what you can do for now, you can do your own WebSocket testing or dumping with this little bit of JavaScript here. And we have another little demo that is the same Waldo tool, the browser exploitation toolkit. But in this case, you can add a bit of JavaScript to it and start fuzzing right away. So what I've done here, oops, that was wrong. Didn't want the specter. So I have two global variables defined that if I change the values of right here, they will change the WebSocket data on the fly. So if I define f_append with a value like and 1 equals 1, this didn't connect yet. Okay. When I do that and I request some information from the client using WebSocket, let's say HTML, we have our little injection at the end. So if this was a database-driven application, we would have a way of injecting stuff. Or I could inject a whole bunch of garbage. I can redefine the f_replace with and hope it dies. All right, so why did I demo this? This is because this is very simple. This piece of code is what enables you to basically debug or fuzz or intercept WebSocket messages. All right, now back. So, as we already talked about, security of the protocol is not there. There is a secure version of the data communication, but there is no security into the protocol itself. We are missing HTTP cookies and form-based authentication and all that good stuff here. And if people have to write WebSocket applications that use WebSockets, they will need to go from their HTTP land to WebSocket land and mix and match them, and sometimes they will mess things around, or not sometimes, but there are huge possibilities for that. There may be confusions, things like you have your secure connection, SSL connection, you established authentication, everything is great, and then you're establishing a WS connection and messing it all up because you're sending everything with open text, or other mishaps. One very interesting point is that masking that was preventing security devices from failing now also makes security devices obsolete, because firewalls, IDSs, and IPSs right now don't have a clue what's WebSocket traffic. They don't do unmasking, so they can't apply the filters or patterns and find whatever they're trying to find in a traffic. That's bad. And a second thing about it is that sorry, I got confused. Second thing is covered channels. So covered channels can be created with some use of entropy, and the data frame has reserved flags that can be played with. The length representation can be manipulated because you can represent the same length in many different lengths of the length field. And the mask value itself can be used as a communication data. So what to do with WebSockets? Should we use it or not? And how should we use it? Well, if your application is really requiring full duplex real-time communication, if it's a video game, yes. But if it's a website that really doesn't care if user's screen gets updated once in half a second or 30 times in a second, probably you don't care. So how to deploy WebSockets securely? Because, of course, it's impossible to tell in little talk how to do that, and honestly, I don't have a clue how to do that. But here are a couple of recommendations. We shouldn't trust. That's a basic recommendation. You shouldn't trust the client, and we shouldn't think that client is a WebSocket compliant client, that it talks pure WebSocket protocol. We shouldn't assume the headers are there or all the data fields are there or reserved flags are not used or stuff like that. Also, if you are a WebSocket server developer, if your Handshake has some initial HTTP handshake has this flavor to it, a little bit difference from others, then you are easy to fingerprint. And of course, we need to be careful with origin control headers here. So one thing to reiterate, WSS is secure WebSockets, but it's just a secure transport. It's not a panacea. You cannot all of a sudden make your web application all secure by just streaming stuff to and from with WSS. And all the basic security concerns are still here. All the good web development practices should be abided. So to sum it up, WebSockets are communication protocol. They are not security enhancement. Basic security still applies, and WebSockets should be looked for by security devices. IDSs, IPSs, firewalls should look for the traffic, for WebSocket, specifically for WebSocket traffic. They should unmask, understand the data. So we should all participate in making things better. OWASP Zap is building the fuzzer. There are many new things coming up. People will start better. People will trust WebSockets more and more if there are more security researches done on the field. So with more and more push towards applications running on a browser, you could see more, not more, but different kinds of application running on a browser. And for example, would be games or or remoting something, like on-live remotes. I think on-live remotes, the desktop Office applications. So for those, I would imagine that those kinds of applications which will use WebSockets. Also, we have these new features in HTML5, like file API. You have storage, and browser becomes an OS by itself. So now you can have maybe, I don't know, BitTorrent server running on WebSockets that sits inside your browser, browser-to-browser, BitTorrent, stuff like that. Yeah. So for FaceTime or other communications, like I think there is a new standard which is going to be part of HTML5, which is based on Skype or Google Talk. Depends on which part you're looking at. Google and Microsoft are pushing for the standard. But that is not WebSockets, though. Well, any other questions? We have time. Well, yeah, thanks. Thanks, anybody.